Okay, today I want to talk to you about your notes number 10, perpendicular lines. Just to let you guys get a heads up, we're going to be doing some constructions with perpendicular lines tomorrow. Yay! Now, I will try to make a video of it, but we've been having technical difficulties. I don't know who's at fault. Really, honestly, I don't. I'm just as frustrated as you guys are, but let's just keep at it. The notes I make for constructions will be a little bit lame because of the fact that I can't actually use the compass when I do the notes. So, yeah, it'll be interesting. Okay, we've got some vocab words. First is perpendicular lines. What are they? And perpendicular lines are two lines that intersect to form right angles. Okay, now I'm going to repeat that. Two lines that intersect to form right angles. It does not say two lines that create 90-degree angles. Okay, that's a whole different step based on the fact that I know some information about right angles. Okay, so tidbit to you, detail that's super important in our class. So what is the symbol of perpendicular lines? It is an upside down T. So there's two things that our definition kind of gives to us. First, it basically says if two lines are perpendicular, then four right angles are formed. And that kind of has to do with, I'm going to do a little diagram off to the side here. If we combine that we have two lines that intersect to form right angles, so this is, I'm going to use a different color. Normally red is the one that tells us. So if I know this angle is a right angle and this is a right angle, I also, vertical angles ensures me that vertical angles are congruent. So he has to be a right angle, he has to be a right angle. So all four of those angles would be right angles. Okay, now I can't go jump into that and prove, but again, this is kind of the line of logic that we could follow. And then if any of the angles now this means when we have two lines that intersect, so if any of the angles formed when two lines that intersect equals 90 degrees, then the lines are perpendicular. And remember that we've got two lines, and then we'll have angle addition postulate will allow me to get side-by-side angles equal to 180, and if one of them is 90, the other would be 90, and then I can do the vertical angles things. So that's what I can gather. But again, that's not what the definition says. The definition stops at two lines that intersect to form right angles. Okay? All right, and then we've got some theorems to talk about. So first is theorem 2-4, so the fourth theorem to show up in chapter 2. And it states if two angles are perpendicular, then they form congruent adjacent angles. This theorem turns out to be a time saver in a lot of proofs. It allows me that if I have, two angles. That's silly. Good thing I caught that. That should say two lines. if two lines are perpendicular, then they form congruent adjacent angles. So normally in a proof, if I want to prove that I have two angles that are congruent, and I know that the lines are perpendicular, then I would use the keyword perpendicular and go with the definition of perpendicular angles. At first I would say if two lines are perpendicular, then they form right angles. If I have right angles, then they measure 90 degrees each. If I have two angles that measure 90 degrees, they're equal to each other, which then, through substitution, and then I'm allowed to take them through the definition congruence to say that they're congruent. This theorem allows me to go from I have two lines that are perpendicular to that two adjacent angles are congruent. So that's pretty fast. So 4 steps down to 2 steps, basically. All right, I'm going to go to the next page for the next one. So we've got theorem 2-5, so 5th theorem in the chapter 2. And it states if two lines, so now it's the converse of the last one, two lines form congruent adjacent angles oops, try that again. Then the lines are perpendicular. So again, the great thing about theorems is that they allow me to get to a conclusion faster than if I go through a series of definitions. Okay, so they're really helpful when it comes to proofs. All right, we got one more, and then I'm going to share with you a couple different proofs. So we've got theorem 2-6, 6th theorem in our chapter 2. If the exterior sides, and this one I'll put a diagram for, of two adjacent acute angles, so very specific types of angles. So adjacent, they share a side in common vertex. Acute means they're both less than 90 degrees. Of two exterior sides, of the exterior sides of two adjacent angles, are perpendicular. So visualize that in your head. We've got the two outer sides of both our angles are perpendicular. That means they form a right angle. What do we know about two adjacent angles that add up to equal 90 degrees? Well, then the angles are complementary. Remember, it's with an E, not an I. Okay? So again, I've got this angle here, and we'll call it angle AOB. And then I've got this guy, and he's ray OC. And the exterior rays, the OC and the OA, are perpendicular, then there would be a right angle, and the measure of right angle is 90, and two angles that add up equal 90 are called complementary. So this one basically is given that ray OA is perpendicular to ray OC. We would be able to prove or conclude that angle AOB and angle BOC are complementary angles, and I'm going to abbreviate it comp angles. Okay, so on the next page, let's go ahead and do a proof. And we are going to be given that line OA is perpendicular to line CO, and that we want to prove that angle 1 and angle 3 are complementary angles. Okay. So let's get a diagram going in this one. So we've got line A. Remember, they're going to have O in common, so we'll make this the O, and this will be C. And then we'll put some angle numbers in there. 1, 2, 3. Okay. And here's something I want you guys to really pay attention to. When you're asked to do a proof, and they've got all the letters there, and you can name the angle by 3 letters, then that's fine. However, if they number angles, the expectation is that you're going to use those numbers in your proof. Okay? And because it gets very confusing with letters, the numbers are much easier to track. So let's start with our given. Line OA, or AO, excuse me, is perpendicular to line CO. And then you have to ask yourself, okay, what's the key idea that's in the given? And the key idea is that we have perpendicular lines. And the only thing I know about perpendicular lines, a couple of different things, is that we have, if 2 lines are perpendicular, then they form congruent adjacent angles. And looking at my diagram, gosh, that's really not going to help me, because congruent adjacent angles would be angle 1 and 2 together, and then the angle that is adjacent to that. So that doesn't look like it's going to work. Let's see what else I know. Definition perpendicular lines, that they're 2 lines that intersect to form right angles. So basically, I think what I'm going to do is pull out the idea of a right angle. Now remember, what we're trying to prove, that angle 1 and angle 3 are complementary angles. Okay, so basically what I need to come up with is that they add up to equal 90, then I can conclude that they're complementary angles. And bing, 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 right angles measure 90 degrees. So all of a sudden, things are starting to move in my head. So the only angle I'm interested in, I know, you know what, I'm going to erase this and do them again, because that's supposed to say C. That's not a very good C that I drew. That's better. So I'm going to say that angle AOC is a right angle. Because remember what the definition said. It said perpendicular lines are 2 lines that intersect to form right angles. There's no mention of 90 degrees. So that's the definition of perpendicular lines. Okay. So what do we know about perpendicular lines? Well, or right angle, excuse me. The measure of a right angle is equal to 90 degrees. Now remember, in the proof I don't use the degree symbols, and that's just the definition of a right angle. Okay, now somehow I got to involve angles 1 and 3, but right now I'm talking about angle AOC. And do you see angles that form angle AOC? Well, I do. So I'm going to use my old friend, angle addition postulate, because I have 2 angles that add up to equal a big angle. Okay, so measure of angle 1 plus measure of angle 2 equals a measure of angle AOC. That's angle addition postulate. Okay, great. But somehow I need to get rid of angle 2 and bring in angle 3. So I'm looking at my diagram, and there's my old friend. Look what kind of angles 2 and 3 are. They're vertical angles. So I can say that vertical angles are congruent. So angle 2 is congruent to angle 3. And that would be vertical angles are congruent, which is theorem 2-3. Okay. Got a couple other things I need to do. Step 5, cannot talk to anybody else because he's an object and everything else is dealing with measures. So I'm going to do that definition of congruence. and I get measure of angle 2 equals measure of angle 3, and that's definition of congruence. So look at all the definitions I'm using in this proof. Okay, I've got a postulate and a theorem, and then the rest have been definitions. All right. So in order to prove that I have complementary angles, I need to prove that the sum of the angles is equal to 90. So let's go back to step 4, and let's substitute in what we know about the measure of angle AOC. Measure of angle 1 plus measure of angle 2 equals 90 degrees. So all we did was substitute. Property of equality. So now we're using a property. Alright, so I've got 1 and 2, but I need 1 and 3. But remember, step 6 says measure of angle 2 and measure of angle 3 are the same. So I can substitute. I get the measure of angle 1 plus the measure of angle 3 equals 90. So again, we've got another substitution. Now, I would never do those two steps simultaneously, ever. Okay? Now, some people may actually call measure, let's see which one. They may call number 7 transitive property of equality because you're replacing a side with a value. So you could do that. And then I'm going to squeeze them in at the bottom. I can say that angle 1 and angle 3 are complementary angles, which is where I'm supposed to end, and that comes from the definition of complementary angles. Now, if you see this proof tomorrow or you see it online, it looks like it's only 6 steps. Well, number 1, if you look at the step 4 in the notes, I combined step 5 and 6 as if it was one step. Remember, that came back from what the book had, and back in my early days of writing this, I hadn't gone back since and changed those notes, noting that I can't go from congruence to equality in a single step. I need to make it 2 separate steps, because it's 2 separate reasons. Okay, it's not definition of congruence, or vertical angles are congruent to get that measure of angle 2 equals measure of angle 3. And note that what I have here is, I forgot to write in the original proof that the measure of angle AOC equals 90, because I just kind of jumped to the gun there. And I wrote that in step 3 in the notes, that measure of angle 1 plus measure of angle 2 equals 90. Well, we don't know that we can write that. So this is actually a more accurate proof than the one in the notes. So we will have to do, if you don't watch this video, we'll have to do some correction in class when I get back. All right, I have one more proof for you. This one is given that we have, oh boy, we're going to have a fun drawing here. Line YD is perpendicular to line YF. We also are going to be told that the measure of angle 7 is equal to the measure of angle 5. We're also going to be told that the measure of angle 8 is equal to the measure of angle 6. And we are going to prove that line XD is perpendicular to line XF. So here comes the fun part. Somehow I need to draw this. Okay, so let me think about what this diagram looks like. Hold on just one second, let me check the book. Alright, so this is actually number 29 off of page 60. So basically what we have are 2 triangles. One that's laying on a plane and one that's coming out of a plane. But one of its sides is on the plane. So I'm going to do my best to draw this. So I will have to eventually get a plane in here. So we've got that guy. And we've got that guy. We've got a plane. So that's a dashed line. Alright, let's put some lettering in. So this is plane M, point D, Y at the top, F over on the right, X at the bottom, and now we got to do a couple of lines. And these guys intersect at point E. Alright, now I'm going to number some angles. And we've got 5 and 6. Yikes. 5 is here. 6 is here. 7 is here. And 8 is here. Okay. So we want to prove that segment or line XD, so I'm going to highlight him in blue. This guy is going to be perpendicular to this guy. So sometimes when I do a proof, I actually look at what it is I'm trying to prove, and I try to go, what do I need just before I get that? So in order to prove that I have perpendicular lines, let's think about it. If I could prove that they form a right angle, if I can prove that they are complementary, or if I can prove that they are congruent adjacent angles, theorem 2-5 says, then the lines would be perpendicular. So let's see if we can do that. See if we can prove that angle 7 and angle 8 are congruent. Okay? And then from YD, line YD being perpendicular to line YF, we can prove that angle DYF is a right angle, which would measure 90 degrees. Or no, same idea, yeah. Think about theorem 2-4. Two lines are perpendicular, then they form congruent adjacent angles. So I can get angle 5 congruent to angle 6. And then I have all these facts about different angles being equal to each other. I bet you we can transitive our way out of this and get what we need. All right, let's give it a shot. Okay, I'm excited. I'm going to use theorem 2-4 and 2-5 in this one proof. Now, here's the interesting thing. You are not going to see the this proof on the notes. I'm going to do it differently than there. And just to remind you, there's always more than one way to do a proof. So let's start with, I'm going to do one given at a time. Well, actually I can do the other two together. So I'm going to deal with this guy. That line YD is perpendicular to line YF. That's given. And theorem 2-4 says if two lines are perpendicular, then they form congruent adjacent angles. Well, the two angles that are formed are angle 5 and angle 6. So that would be if two lines are perpendicular, then they form congruent adjacent angles. Okay? Now, in order to have step 2 talk with the other givens, I'm dealing with measures, so I'm going to have to go into measures. So measure of angle 5 equals measure of angle 6. And that would be definition of congruence. So then let's go ahead and bring in the other two givens. So we have measure of angle 7 equals measure of angle 5. And we also have measure of angle 8 is equal to measure of angle 6. Now remember, you could do all givens always in one step, but as I'm trying to teach you how to do proofs, I'm going to separate them out and deal with what I learned from each one, okay? All right, so remember what my goal is. If I can get angle 7 congruent to angle 8, then I can use that theorem 2-5, which says if two lines form congruent adjacent angles, then the lines are perpendicular. So let's see if I can get that. Well, we're told in the first of the last two givens that the measure of angle 7 is equal to measure of angle 5. So I can substitute in for step 3 measure of angle 5. I can put in measure of angle 7. And where it says measure of angle 6 in step 3, I know from the second of the givens here that the measure of angle 8 is equal to the measure of angle 6, so I can substitute that in. Now, what you can say is this is just one big transitive problem, so you could either use transitive property of transitive property of equality, or you could say substitution property of equality. I really don't care. But this is the way I've decided to do it. So then, though, remember what the theorem says. If two lines form congruent adjacent angles. So now we need to go to congruence. So if we don't meet every criteria, then we can't use it. So back to definition of congruence. And then we can get that line XD is perpendicular to line XF if two lines form congruent adjacent angles, then the lines are perpendicular. All right? All right, good luck with that.